a cell gives balance with 85 centimeter of a potentiometer wire. It means this is a cell. We keep this cell, this one. This is a cell connected through a galvanometer, gives the balancing point, that is Jackie 1, which is L1 is equal to 85 centimeter. At 85 centimeter. It means we have connected a cell with internal resistance R, and we move this jack here and there, and we get this balance point, that is, it gives null deflection. And at this balance point, this potential between A and J1 gives the EMF of this battery. Therefore, we can say at balancing point, condition 1, at balancing point of cell, the balancing length is equal to 85 centimeter, and K is equal to potential gradient of wire AB, potentiometer wire AB, which is equal to K. Now we can say at this balance condition, this gives the EMF of this battery. It means, what is this? V potential difference Ej1 is equal to K into L1, which is equal to this one. Or we can write this is equal to K into L1. This is the first equation we got, first condition. Second, when terminals of the cell, this is the terminals of the cell, is shorted through a resistance, Shorted means connected, a resistance is connected across it. Shorted through a resistance of 7.5 ohm. The balance point is 75 centimeter. That is, here the balance point L2 is equal to 75 centimeter. We have to remember one thing from the battery. This is the battery with, so this battery having an internal resistance R and an external resistance R. This is equal to R is connected. This is R, EMF R, and the current through this. And what will be the EMF of the battery? We apply the Kirchhoff law. This is positive minus negative terminal, and current is flowing this way. This is positive, negative. Current is flowing like this. This is positive, negative. Applying KVL from here to here. We are going from here to here. Positive potential, that is I is flowing I into R, and again we are flowing from here to here, plus I into the resistance, that is the potential. And going negative, this is negative, this is positive, minus epsilon is equal to 0. This is KVL. R, this battery EMF is equal to I into R plus R. As it is, we have driven one more relation for this one. From this behaves as a battery shorted with an external resistance. That is, a battery with internal resistance having an external resistance. From the battery basics, we have derived this condition also. And what is when it is connected, this one, and when it is connected, the balancing length is equal to 75 centimeter. That is J2. That is 75 centimeter. Here we have to remember one thing very carefully. See, when a battery with internal resistance is shorted, is connected, a resistance or across it, it gives this potential is equal to this potential. This potential is nothing. When it is not there, it gives the value of the EMF. But when it is shorted, with an external resistance. This is equal to this, that is point A and point we can say C. This is point A and point C. It gives the terminal potential, the potential between the two terminals of the battery. This balancing lens, this balancing lens. This is 85 centimeter. This balancing lens gives the terminal potential of this cell, not the EMF of the cell. This we have to give. Remember, when R is shorted with cell of EMF E having an internal resistance of R, the balancing lens length gives terminal potential difference of the cell. This point we see here at balance point, without this resistance it gives the EMF, but when it is shorted, this length, earlier this was the length, now this length gives the terminal potential of the cell. What is terminal potential of the cell? For the cell, the terminal potential is this one, V, and this is the EM of the cell. Okay, so what is it? Means the terminal potential of the cell at balance point. Now it is balanced now at this point J2. First it was here, now it is balanced at 2. What is this V? The terminal potential is equal to potential difference between A into J2, which is equal to K into L2, because as it is known, the potential difference across any length is equal to potential grade into that length. So that only we are using. The terminal potential difference is equal to K into L2. That means we can write second equation, V is equal to K into L2. Also, from here, what is V? So we want to find out what is, we divide E by V. E is equal to K into L1. E is equal to K into L1 and V is equal to K into L2, which is also equal to, what is the value of E? E value is equal to I into R plus R, and V, what is the terminal potential? This potential between these 2 points, and this potential both are same, because both are in parallel. Potential across these terminals, 2 terminals of battery is equal to terminal potential difference, which what is the potential here? That is also the same potential here also. That's why we can write V is equal to I into R. This we are writing it here. So therefore E by V is equal to I and I cancel, is equal to R plus R divided by R. So we can write, now we want to find out now E by V. What is the value of E by V? E by V, and this is V is equal to K into L2. E by this we have drawn this one. E by V is equal to L1 by L2. Therefore, E by V is equal to L1 by L2 is equal to this. We can write 1 minus R by R. Or we can find out in terms of this. In terms of R, we can find out. Therefore, R by R is equal to 1 minus L1 by L2. 1 minus L1, L1 by E by this V, R 1 plus R by R, or R by R is equal to L1 minus L2 minus 1 R, and therefore we can write what is the value of R. The value of R, we can write it here. Therefore the value of R is equal to we can write it here. value of R, or from this equation we can write R is equal to L1 by L2 minus 1 into external resistance R. This already we have derived it to find out the internal resistance of a cell. This relation already we have derived it. Again we are deriving it once again. Now from here we have to find out the internal resistance of the cell. What is the internal resistance? The internal resistance of the cell is equal to L1. What is the value of L1? L1 means this distance, 85 centimeter. L1 85 centimeter divided by L2. L2 is given by 75 centimeter minus 1 into R. What is the value of R? It's equal to 7.5. Therefore, R is equal to 85 minus 75 divided by 75 into 7.5. It's equal to 10 divided by 75 into 75 divided by 10. This can be written as 75. This one cancelling this one, we get 1 ohm. The internal resistance of the cell is equal to 1 ohm.